Hi everyone, welcome back to my number set series. Today we're going to be doing something I call multiplying with square roots. So by that, I mean questions where the answer is of course an integer, but the question statement involves square roots with multiplication inside them. So the question is, how can we do this? And the real difficulty lies not in the actual multiplication, but in getting rid of the square root correctly and quickly. For example, we might encounter something like the square root of 75 times 108. Now, one of the most powerful pieces of knowledge that we're going to use for these problems is that we know the answer is an integer. The answer will always be an integer, so we can kind of use this to inform our decisions regarding these problems. For example, if the square root of something is an integer, that means the thing inside the square root has to be a perfect square. So we know that this is a perfect square, we just have to figure out how to write it in a more obvious way. So the way we do that is by kind of searching for perfect squares. For example, you might look at 75 and 75 is not a perfect square, but it has a perfect square inside it, right? 75 is 3 times 25 and 25 is a perfect square. So now if we can just get this 3 to vanish, then we'll have done it correctly. Luckily, and well, not luckily, because this is the way the problem was engineered, this 3 and this 108, they create, when you multiply them, 324. And 324 is another perfect square. So what we're doing is we've rearranged this 75 times 108 into actually 25 times 324. And then we know that the square root of 25 times the square root of 25 times 324, using this property, is the square root of 25 times the square root of 324. In other words, we just do the square roots independently and then multiply. So it's this, which is going to be 5 times 18. So our answer is 90. And that's how we basically always do a problem like this. So next example, the square root of 5 times 13 times 585. Now, the scariest part about this problem is, of course, that 585, right? We don't often see numbers that are this big and, I would say, kind of ugly, right? 585, it's not a perfect square. We can't really tell at first glance if it has any perfect squares inside it. So what can we do? Well, my thought process when I saw this problem was, okay, we've got 5 and 13 here. 5 and 13 together, they make 65. 65 is, it doesn't have any perfect squares inside it. But I know that the answer has to be an integer, right? Which means there's got to be a 65 inside this number. In other words, we know that we're going to be looking for a 65 in here so that it can cancel with this. So now we know we can divide this by 65. When we divide it by 65, we get 9. So 65, 65, 9. So our final answer is going to be the square root of 65 times 65 times the square root of 9, right? Because this expression is 65 times 65 times 9. So then we get 65 times 3, which is 195. Next question is going to be pretty simple. The square root of 24 times 150. And with this question, I think it kind of exemplifies one of the things about these questions is that you can pretty much always do it 2 ways, right? We could have also done this one 2 ways, as I'm about to show, because the square root of 24 times the square root of 150, we can look for our perfect square inside either 24 or 150. Now, I will admit my force of habit leads me to always look for the perfect square in the first number, but in some cases, it is much more efficient to look for it in the second number. For example, let's try it with the second number here. The square root of 150. Well, what's 150? It's got a 5 in it, it's got a 3 in it, it's got a 2 in it. The most important thing is that it's got a 25 in it. We should be able to recognize 150 as you gain more experience as 25 times 6. And this 25 is a perfect square, so that's all good. Now we've just got to focus on getting rid of the 6. And what do we have to get rid of the 6? 6 and 24. What do 6 times 24 get? 144, which hopefully we know is a perfect square. It's 12 squared, right? So that means our answer is going to be, let me rearrange this really quick. This is 25 times 144. So our answer is the square root of 25 times the square root of 144, which is 5 times 12 equals 60. And we also could have done this another way, right? we could have looked for our perfect square inside of 24. What 24 would have given us is 4 times 6, so that's 6 again. And that 4 we leave alone, but that 6 we multiply into 150. 6 times 150 is 900, and 900 would have given us 30. 30 times the square root of 4 is 30 times 2, which would have given us, again, 60. So there are usually, pretty much always, 2 ways to do these problems. But, I usually just run with whatever one I see first. Now, these 2 problems are going to be pretty similar. The square root of 28 times 112. Now, this is a tiny bit different from the other ones, so my apologies. It's a tiny bit different because what we have here is kind of a special case. In all of these other questions, 75, 108, 5, 13, 585, 24, 150, it was never explicitly in this form. And what I'm talking about when I say this form is that 112 is a multiple of 28. We don't have to really look for a perfect square in 112 if we can recognize it as 28 times 4. But of course, some of you, I know, will not be able to recognize that, and that's totally fine because you can do the problem without it. So I will show you how I would do the problem with and without that realization. With that realization, it becomes quite a bit easier because we can write this as the square root of 28, right, this 28 times 28 times 4. And so this is the square root of 28 times the square root of 4, which is simply 28 times 2, which is 56. But if you don't recognize that immediately, that's fine, because we can also just do the thing where we search for a square root. So if I were to search for a perfect square inside of 28, what I would find is 4 and 7. I'm sure that's what most of you think of when you see 28 anyways. So this 28 would have given us 4 and 7. This 4 is a perfect square, so we're going to leave it alone. And we try to deal with the 7 now. This 7 and 112, what do they make? You can multiply them, 7 and 112. They give you 784. And if you've memorized your squares up to approximately 35 or 40, like I recommend, hopefully you have, you'll recognize that this is 28. 28 squared, that is. So we can also say it's this. It's multiplication. So this is, again, 2 times 28, which is 56, once again. And a third way we could have done this is by looking for a perfect square inside of 112. What that would have given us is 16 times 7. So we would have had 16 times 7 times 28. Then we would have done 7 times 28, right? 7 times 28 is 196. So you have the square root of 16 times the square root of 196, which is 4 times 14, which again is 56. So lots of ways to do these problems. So don't be worried if you can't make immediately the critical observation, because you can absolutely still do it. And one last method that we can use for this, 28 times 112, is to first proceed as we did in the first method by decomposing 28 into 4 times 7. And now that we know that we have a 4, we can leave that alone. And we know that we have a 1, 7, but 7 isn't a perfect square. So we must have another 7 somewhere in order to make this a perfect square, right? Where does that 7 come from? It must come from the other number. So we can, with the knowledge that this is a multiple of 7, we can decompose it into 7 times 16. So it's 4, 7, 7, 16. So this becomes 2, these 2 become 7, and this becomes a 4. And then, once again, we can multiply 2, 7, and 4 and get 56. That is the last method for this one. Now, our final question, hopefully these have prepared you for this one, so try to get ahead of me on this one if you haven't already. Square root of 32 times the square root of 72. Now, I would say it's pretty easy to look for a perfect square in either of these, but I usually just start with 32 because it's the first number. 32 is going to be, hopefully we might recognize this as 2 to the power of 5, but in this problem, it's more important that we see it as 16 times 2. So this is 16 and 2. So the 16 is a perfect square, so we've got that. So now we look at 2 and 72. 2 times 72 is 144. So we have the square root of 16 times the square root of 144. So we have 4 times 12, which is 48. And a little bit of a sanity check before we write the answer down, maybe. The square root of 32 times the square root of 72. That is known as the geometric mean. And so it should be in between 32 and 72. 48 is in between 32 and 72, so we can say, okay, this looks good, and write that down, or box it. So yeah, that is multiplying with square roots. And hopefully, you'll recognize that the hardest part is not really the multiplication, it's getting rid of the square root. So if you can train yourself to kind of remember the divisibility, the factorizations of these numbers, if you know prime factorization, that could help, but it's not necessary. The most important thing is that you think quickly when you see these numbers. You can kind of decompose them in your head, and then that is going to give you the ability to get rid of the square roots and return back to normal multiplication. So I hope you guys took something away from that. If something doesn't make sense, maybe Google it or comment, I will answer. And yeah, that's it for today, and thank you for watching.